Have you ever really thought about what would happen if you fell into a black hole? I mean, it's one of the biggest, wildest questions in all of physics. And the answer, well, it's not just strange. It completely rewrites the rules of reality as we know it.
So let's imagine you're in a spaceship and you're taking that final plunge. What would someone watching from a safe distance, like me, actually see? Would you just blink out of existence, or is it something a whole lot weirder?
You see, as you get closer to that cosmic drain, the fabric of space-time doesn't just get warped. It's way more profound than that. The fundamental rules of space and time, the very dimensions that make up our universe, they actually trade roles. To really wrap our heads around this, we need to take a little trip. We're going to follow a mission to the very edge of a supermassive black hole and see exactly how this all plays out. Okay, so here's the setup. We've got a mothership hanging back at a safe distance, 1,000,000 kilometers away. From there, a smaller scout ship is going to make the daring approach. And our target is a pretty hefty black hole, about 12,000 times the mass of our sun. Now, the size is really important here because a black hole this big has gentler tidal forces. That means our scout ship won't get ripped apart into spaghetti before we even get to see the really weird stuff. So the very first bizarre thing our scout ship is going to encounter has nothing to do with space. It has to do with time. We know from Einstein that really strong gravity slows down time. Well, near a black hole, that effect goes into absolute overdrive. So, from back on the mothership, as they watch the scouts get deeper and deeper into that gravity well, the scout's clock will seem to tick slower and slower and slower. Every single second that passes on the scout ship will look like it's stretching out for ages to the crew watching from safety.
Let's put some numbers on this, because this is where it gets wild. Let's say the scout ship manages to hover just 1 single kilometer away from the event horizon, the edge of the black hole. From the mothership's point of view, they watch it stay in that position for 3 full days.
But, and this is the part that breaks your brain, for the crew on the scout ship, only 23 minutes have gone by. They've been there for less than half an hour, while their friends back on the mothership have aged 3 whole days. It just goes to show you, time isn't some universal constant. It's completely relative to how much gravity you're in. And this stretching of time has an effect you can actually see. It's called gravitational redshift. Basically, as the light from the scout ship climbs out of that massive gravity well to get to the mothership, its waves get stretched out. So, let's say the scout is shining a bright green light. From 100,000 kilometers out, that green light already looks deep red to the mothership. As it gets even closer, say 50,000 kilometers, it fades from view completely, shifted all the way into infrared light. And at that final 1 kilometer spot, it's now so stretched it's in the far infrared. To the mothership, the scout ship basically looks like a frozen, fading ghost on the edge of forever. But you know, hovering is one thing. What happens when the scout ship finally cuts its engines and crosses that ultimate boundary, the point of no return? This boundary is the event horizon. And you gotta understand, it's not a physical wall you can crash into. It's a point in space-time. Once you're past it, the pull of gravity is so powerful that you'd need to go faster than the speed of light to escape. And since nothing can do that, nothing gets out. Ever. Now, to really, truly get what happens at the event horizon, we have to kind of throw out our normal ideas of space and time. So let's pause the journey for a second and build a really simple model of the universe. It sounds a little strange, but trust me, this is going to make everything click. Okay, first, just picture a normal 3D space, but with a vertical line running right down the middle. Now, let's add a rule. The only rule is that all movement must have an upward component. You can go left, right, forward, back, but you are always, always moving up. That up direction is our stand-in for time, right? Because in real life, time only moves forward. Now, let's draw a cylinder around that central axis. This cylinder, that's our event horizon. And inside the cylinder, the rules are about to get turned completely upside down. Because this is it. This is the most profound, most mind-bending property of a black hole. This is the moment where space and time literally swap places. So check this out. Outside the horizon, our compulsory one-way street direction is up or forward in time. We can move around freely in space, but we are all being dragged into the future, whether we like it or not. But once you go inside that cylinder, inside the event horizon, the roles flip. Now the compulsory direction is inward, toward the center. The spatial dimension becomes the one-way street. You have to move toward the singularity. It's as unavoidable as tomorrow used to be. In this quote just nails it. Trying to fire up your engines and stop your inward fall inside a black hole is literally like trying to stop time itself, or trying to travel into your own past. It's not about having a strong enough engine, it's a fundamental property of the reality you're now in. The future is no longer a time, it's a place, the center. So what does this actually mean for our scout ship crew? They've crossed the horizon, they're inside. What happens now? We always picture the singularity as this infinitely tiny, dense point right in the middle. But that's not quite right. Because space and time have swapped roles, the singularity isn't a place you travel to. It's a moment in time that you arrive at. For anyone inside that event horizon, it is the end of time itself. It is their future. And it's unavoidable. So, how long does that future take to arrive? For our scout ship, falling into this specific black hole, the entire journey from the moment they cross the event horizon to the moment they hit the singularity, the end of their time would take just 0.1857 seconds. To the mothership, they are frozen at the edge for eternity. To the crew, their entire existence ends in less than the blink of an eye.
And this whole thing leaves us with one final, absolutely mind-melting question. In our universe, we experience time as this relentless one-way street, always pushing us forward, kind of like that compulsory inward journey inside a black hole. So, what if our entire expanding universe, with its unstoppable arrow of time, is really just the interior of some other, unimaginably vast black hole? It's a thought that really puts things in perspective, doesn't it?